Hey everyone, here we are today. Today we are talking and building upon yesterday's lesson. We are talking about chemistry again, but today we are talking about how atoms bond together. So let's just go through a basic review of atoms with you. First off, you remember that atoms are small things, and those small things are made up of even smaller things, subatomic particles. There are three subatomic particles: protons, neutrons, electrons. Protons, neutrons are found in the nucleus of an atom, and electrons are buzzing around on the outside of that atom. Now we know that atoms will never change the number of protons they have, but instead will change the number of electrons. And that's going to be incredibly important because that's what is going to build on the process of bonding. So that is how we are actually going to talk about bonds being formed between atoms. So without further ado, and before I continue to lose your attention, I'm going to move on down to the corner and then I'll let you guys kind of watch the screen as I talk your way through it. So here we go. All right, and I'm down at the corner now. So let's talk about bonding. When we talk about bonding, we're talking about multiple atoms joined together. And when multiple atoms are joined together, we form a compound. Now, a compound can sometimes change the behavior of those atoms. So things like salt, for example, table salt, which is sodium and chlorine combined together. If you put a piece of sodium into your mouth, it would explode and it would react with the water in your mouth and literally cause a massive explosion and blow your mouth apart. Right? You put chlorine directly into your mouth, you probably end up dying. Right? Chlorine is a very toxic substance. But sodium and chlorine combine together, they bond together to form table salt. And many of you consume copious amounts of salt every day and don't even think anything of it. So the idea that we can bond things together and change the properties of those atoms is incredibly important. So that's what we're going to kind of talk about today as we talk about different types of bonds. So on the screen here, let me just pull up my pen real quick so I can annotate on here. Here we have a water molecule. And so if I looked right here inside this circle, I have a normal hydrogen atom. So I have one proton located in the center, and I have one electron buzzing around the nucleus of that hydrogen. And if I drew my other circle over here, there's another hydrogen atom. And then this big circle, which I'm going to draw, is a complete oxygen atom. Now, in the center here, you can see it's written, there's this 8 plus. That because it means there's 8 protons inside the nucleus of an oxygen molecule, or I'm sorry, an oxygen atom. All right. So now what happens is these different three things are all going to start to share electrons because they want to make sure every molecule is happy. And so one of the things that's really kind of confusing to a lot of people is the idea of a valence shell. And I probably should have spent a little bit more time discussing a valence shell with you, but I think I'm just going to try to jump into it here. A valence shell is the outermost level of electrons. And for most atoms, that outermost shell can hold 8 electrons. So that's really important to understand. It holds 8 electrons. Now, in this oxygen, when I drew this circle around the oxygen here, I'm just going to kind of re-outline it. That circle around there, how many electrons are in that valence shell? Well, there's 1, 2, 3, 4, 5, 6. All right. So it's not really happy. All right. It wants to get to 8. Now, is it easier for this atom to lose 6 or gain 2? Right. So it can get to 8. So it's either going to lose its entire outer level and drop down to its full inner level, or is it easier to just gain 2 more electrons to fill up that outer level? Now, this is a little confusing because you don't know how hard it is to gain or lose electrons. But let's just say it's the same amount of energy to do both. In this case, that water molecule is like, well, that oxygen only needs 2 more, and hydrogens each have 1. So this electron from hydrogen will go and join up here, and this hydrogen will go and join up here. Now we have 8 electrons buzzing around that oxygen. So that oxygen's happy. But what about the hydrogen? The hydrogen's not happy now. right? The hydrogen, now this is where it's kind of confusing. Hydrogen, that first energy level, so you see how hydrogen only has one energy level associated with it, and the oxygen has two. All right, here's one, here's two. Um, what is actually happening here is that inner level, that number one level on every single atom can only hold two electrons. It can only hold two electrons. So hydrogen here, by having this electron being shared from the oxygen on both of these, now all of a sudden it is happy. So everything is being shared. So that's what's actually going to happen here. This hydrogen wants to have two electrons, and it does. This hydrogen wants two electrons, and it does. And this oxygen wants eight electrons, and it does. So what's actually going to happen, sorry, I keep clearing all the ink off here back and forth, but this will kind of join up and go around the oxygen at times, and this will join up and go around the oxygen at times, but this will sometimes go around the hydrogen. So everyone kind of shares electrons here. And that sharing of electrons, that constantly moving back and forth of electron, is going to hold that together. I know I spent a lot of time talking to you about just this very, very simple water molecule, but let's go into talking specifically about bonds. So there's two major types of bonds. And the big deal with the bonds is that they're gaining or losing electrons or they're sharing electrons. Those are the big two. They never gain or lose protons. Make sure you understand that. They never gain or lose protons. That would make them a completely different atom. But they will gain or lose electrons to fill out that valence shell. Now, there are two major types of bonds. There are covalent bonds and ionic bonds. Yes, there's other types, but these are the two major types that we need to know for biology class. Chemistry class, they'll teach you more. All right, but right now in biology class, this is all we need to know. Covalent bonds are when you share the electrons kind of evenly, what we saw with that water molecule. Ionic bonds are really going to be more of the stealing of electrons. So one atom is going to be more what we call electronegative and actually is able to steal it. When I was in college, my chemistry professor referred to him as the Hulk Hogan of atoms. So whoever's more Hulk Hogan-y can steal, can beat out the other atom and take those electrons. When you take those electrons, you become negatively charged. When you lose electrons, you become positively charged. And like a magnet, positive and negative stick together. So that's an ionic bond. Ionic referring to ions. And remember in the previous lesson, we learned about ions, which are just positively or negatively charged atoms because they've gained or lost electrons. So here's a look at covalent bonds versus ionic bonds. Covalent, they are sharing these electrons, so they're going to just kind of work their way around. So both of them are happy. Whereas with an ionic bond, this is the more Hulk Hogan-y of the atoms, and it pulls the electrons. So this has a negative charge, and this becomes a positive charge, and positive and negative form an electrostatic bond together. They both are very, very common types of bonds, right? But this is how different things are shared. So there's a lot of energy now being shared between these two atoms when they form a bond. Now, let's talk about some famous elements because we want to make sure we understand the elements first. Gold, silver, oxygen, carbon, hydrogen, nitrogen, all of these are famous elements. Now, they will eventually form different compounds, but let's go through some big and important compounds we will talk about this year. Compounds like water. Water is not an element, water is a compound. Glucose, salt, carbon dioxide, all of those are very, very famous compounds. Do you understand the difference between elements and compounds? They're different. They are very different. Elements are found on the periodic table. Compounds are bonded together. And remember, through the process of bonding, you can change your properties. The way in which you behave can be changed with different compounds and different elements involved in those compounds. Now, let me talk to you about one more small little thing. Hydrogen bonds. Now, why didn't I talk about hydrogen bonds yet? Because hydrogen bonds are not a true bond in the sense that they're not gaining or losing electrons. What they are, however, doing is because of the arrangement of the electrons and the arrangement of the atoms in the compound, there is a positive end and a negative end of the molecule. So think about like that, like maybe your forehead becomes positively charged and your feet become negatively charged. That means you would just want to walk around and put your feet on someone else's head. They'd be charged together in that way. Right? That is how a water molecule will stick together. And it's going to be really important next week because we're going to talk about all about the properties of water, which are really based on strong hydrogen bonding. But in this picture here, you see the positive end is sticking to the negative end. So they kind of form this electromagnetic sticking together. And that's what's going to start to hold water molecules together. So water molecules and a bunch of other compounds will oftentimes behave interestingly because of hydrogen bonding between the molecules in that situation. So it could be a bunch of water. All the water will stick together. Again, it's not the hydrogen and oxygen sticking together, which they are bonded together, but it's the positive end and the negative end of water molecules that are holding them together. Now, when we talk about chemical reactions are extremely important. Chemical reactions are going to change substances into different substances by breaking and forming chemical bonds. So there's a couple examples of what will happen within biology. So let's talk about that. Um, excuse me. All right. So when we talk about different examples of chemical reactions within our class, things like building protein molecules are going to be extremely important. We're going to talk about chemical reactions that are going to build protein molecules together by joining amino acids together. Now, when we talk about chemical reactions, you can either absorb or release energy. And this is really important to understand. A chemical reaction will either give off energy because the energy in the bonds is being broken and released, or it needs to put energy in to fix and make those bonds because then they're a high energy bond. Now, if it gives off energy, it's referred to as exergonic. Exergonic is giving off energy. And then it could also be endergonic in that it's absorbing energy. So if we give off energy, it's going to be exergonic. And if it's absorbing energy, it's going to be endergonic. And it can also be exothermic if it's giving off heat, or endothermic if it's absorbing heat and cooling down. Now, in a chemical reaction, there are two major parts. Okay, two major parts of a chemical reaction. You have the reactants and you have the products. Reactants go into a chemical reaction. So it's really important to understand that reactants go in and they form the products, much like you would do in a math class. All right. So in this reaction here, we have two hydrogen compounds going together with two oxygen, or with an oxygen molecule, and it's forming water. So we have hydrogen gas plus oxygen gas, and it forms water. And as the bell is ringing right now, that means that is the end of my little lecture right now as well. Hopefully you understand the little basics of chemistry. If you have any problems, questions, comments, concerns, please, please, please send me an email or try to stop into an office hour, and I will make sure that you guys get cleared up on this stuff. All right. If not, a little easy assignment for you today. So have a great day, and I look forward to seeing you guys next time. All right. Bye-bye.